Okay, so I think I'm recording Lab 51. So 51, last recording. I'm so excited. And so let's see, 9 questions. We can do it. Pay-per-view. How do I get on pay-per-view? Don't look at my messy room. Okay, so here we are, Lab 51, Kiwi. And use the graphing method to find the solution. Oh gosh, I'm going to have a ruler. Okay, so y equals 2x minus 3. So I'm graphing this equation. I'm picking 0, get -3. Picking 1, these are my favorite points. I'm getting -1. All it takes is 2 points. 0, -3. 1, 2, 3. 1, -1. A line. Okay, so I've drawn that line. This represents all the solutions to that first equation. Now I'm going to draw this line. 2x plus 3y equals -1. And right away I notice that my favorite points, x is 0 and y is 0, lead to fractions. If x is 0, then y is -1/3. And if y is 0, then x is -1/2, which is not so bad. So I'll pick that one. 0, and then x would be -1/2. But I'm kind of like, I need it. I mean, one fraction is bad enough because I'm trying to find where these intersect and where this line intersects. So when I draw this line, when I draw that line in there, I want to see where they intersect. And when you have a half as your point, then it's really hard to get a crisp line. You know what I mean? And so, one thing that I was telling the people in class that you could use is you could use the one of your algebraic methods to find the solution. And then if you knew the solution, you could plot this point and the solution, and you would for sure get a nice line and you would know exactly where it crossed. And so that is a possibility. If you don't want to do that, if you feel like, oh nope, the graphing method is for finding the solution, and I don't want to use the solution to find the graph, well, you could sit here and try to come up with whole number points, um, and that would be fine and dandy because this is a 1. If I put a 1 in there, then that's going to be, when I put it on the other side, I'm going to get 3, and that would sort of work to get a nice point. And in fact, that would be, so that, I mean, I'm just saying you could start figuring out. I don't know, I would probably use the substitution method. I'd probably say, okay, let me use the substitution method. So it goes like this: 2x, right, plus 3y. But instead of y, I want to say what y is equal to, because this one must solve for y. So I'm going to put parentheses right here, and I'm going to put in there what y was equal to: 2x minus 3 equals -1. So I still have this equation: 2x plus 3y equals -1, but I have the special way of writing y. So I blended the two equations together. So this is 2x plus 6x minus 9 equals -1. So this is when I add 9 and I combine like terms, I get 8x equals 8. So x is 1. So x is 1. And then I want to plug that in to find out what y is. So then y equals, and I'm right back here at this top equation. I could use the bottom equation too, but it's a little more difficult than the top equation for solving for y, is 2 times 1 minus 3. And you might be saying, oh, well, we already did that. We got -1. Wonderful. So our over -1/2 up 0. So that's right here. And then -1, 1. And draw the line through it. And of course, it's intersecting there at that point. Coincidentally, it's a point we had already found. And so I found the intersection point using the substitution method. And that's what they were asking me to find: 1, -1. And then in order to get full credit, right, I drew both lines. And so there's line 1 and line 2. And then the intersection point is the solution. So yay, I did a good job on that. And now I'm on to a sequence, number 2. So let's see, I'm asked to find S20. So I'm hoping that it's either geometric or algebraic, because arithmetic, algebraic. I made that up. And so I'm hoping it's one of the two, because I have formulas for geometric for finding S20, which means the sum of the first 20 terms. And if it's arithmetic, I have a formula for finding the sum of the first 20 terms. And so I'm just kind of looking at it and I'm thinking, if I multiplied by 3, if I multiplied by 3, if I multiplied by 3, well, let's make sure 18 times 3 is 54. Yeah, it is. Great. Now, I just kind of saw that. I could have said if I add 4, well, I can see that if I add 4, I don't get to the next one, so it's not arithmetic. If you're wondering, well, if I'm not sure, how can I figure that out? Well, when you're testing if it's geometric and you're not sure, R equals A2 divided by A1. Now, A2 is 6 and A1 is 2. So that gives us a ratio of 3. And then you test. If I multiply by 3, do I get all of them? Yes, I do. But sometimes I have a hard time figuring out what it is. And this one wasn't hard. But if there could be one that was hard, and sometimes it depends on the numbers. I mean, if the numbers were crazy, what if the ratio was 2.5? Or if the ratio was, 10.5, whatever, -3, then maybe it's harder. Anyway, so this one was good. Okay, so it is geometric. I just tested that. Yep. So that means the formula for A sub 20, this is the formula for the sum of any terms. You need to know the first term, and you need to know the ratio raised to the n, which is 20, minus 1, divided by r minus 1. So the only two things that you need to know is the sum of how many terms and what the ratio is and the first term. So good news, we know all that. So S is 20, S of 20. A sub 1 is the first term, which is 2. The ratio is 3 raised to the 20 minus 1 divided by the ratio is 3 minus 1. So I'm literally just putting that in my calculator. So fraction key 2 times, and then 3 raised to the 20, and then minus 1, and in that parenthesis, and then 3 minus 1, and I get this huge number. And a lot of people were asking me in class, well, could that huge number be correct? And the answer is, well, think about it. If you just kept doing this, multiplying by 3 until you had 20 terms, and then you added them all together, well, right here at 54, they're not that large, but when you multiply that by 3, that's going to be 150 plus 12, 164 or something like that. And then you times that by 3, and that's going to be more than 400. And then you times that by 3, and that's going to be, more than 1,500. And then you times that by 3, see what I'm saying? And you're going to get all these 20 of them. And so, yeah, you're going to get a really large value. And could I find it brute force that way? And the answer is, yeah, I could. And it would take longer, maybe not longer than me sitting here gabbing about it, but it would definitely, that's a really big number. That's a billion, though. 3 billion. Oh, my goodness. Okay, determine the general form. So I'm hoping that it's arithmetic or geometric, because then the general form is an equation that I can look up and use. If it's not either one of those, then I'm going to have to figure it out just by trying to figure out the pattern. And so I'm thinking, well, is it arithmetic? So I'm like 5 to 8, that would be adding 3. And then if I added 3, I would get 11. If I added 3, I'd get 14. And I'm like, oh, yeah, it is. It's arithmetic. if I multiplied, well, 5 times, it doesn't make a nice thing to multiply, but that doesn't mean that it's not geometric. I already decided it was arithmetic, but it doesn't mean that it's not geometric. You would have to test it. I mean, you would do on your calculator, you would say a sub 2 divided by a sub 1, 8 divided by 5. And that would be what I would be multiplying by 8 over 5. So 8 times 8 over 5, so times 8. Do you get the next term, 11? No, I got 64 over 5. Okay, then it's not that. So, but I've already decided it was arithmetic. So even if the numbers are not as nice, oh, I put an E in there, and it goes ME. I almost spelled it wrong. And D is 3. Okay. So the term, the nth term, the formula for it is this. Because it's arithmetic, and we know our first term takes your first term, 5, and D is 3. And then you should not leave it like this. You should simplify it, because you're a math person, and math people simplify things because that's how they are. So distributing the 3, and then I get 3n plus 2. So 3n plus 2 is the general term. So we did a lovely job on that. And you're like, oh my gosh, those 3 problems were shorter than the last 3 problems on the other lab. And it's true. Solving. So I'm supposed to solve here. And I'm like, okay, I only see x to the first, which makes it linear. So if it's linear, you got to distribute. If you have any distributing to distribute, you can put a 1 here if it makes you happy. So that's 8x minus 2x plus 4 equals 21. So that combining like terms, 6x plus 4 equals 21. And then you're supposed to get them separated, the numbers from the variables. So taking away 4. And so 6x equals 21, take away 4, which may or may not be divisible by 6. You get 17, not divisible by 6. It's okay. Fractions happen. Life goes on. So x equals 17 over 6. I certainly can check my answer, and it's certainly a good idea to check your answer. And when you check your answer, you would check in the original. So 8x, maybe I'll do the answer thing. That's even though 17 over 6 is not that bad. So there's 17 over 6. So I'm going 8 answer minus parenthesis 2 answer minus 4 parenthesis. Remember, the answer is 17 over 6. Hit equals, better get 21. Yay, got 21. So that means that it was right. Okay, so here we are with an absolute value. And I have my note cards here on solving absolute values. I have to have the absolute value bars all by themselves on one side of the equation. So I'm going to add 2 to get 6. And it matters whether or not this number over here, it matters if it's positive, negative, or 0. You're going to do something different if it's those different things. If it's positive, then I'm going to split this into 2 cases. So because 6 is positive, because positive. If it's negative, then I'm just going to say no solution, right? Because positive, I know that there are 2 no cases I was going to write. What am I doing? 2 cases. And those 2 cases look like the stuff, negative 2x plus 1 equals negative of 6. And then and then the other case, negative 2x plus 1. So you leave the stuff in the inside exactly the same, and then equals positive 6. If you're wondering how it works, is that you've got this absolute value. I'm putting my fat finger over it, and I'm saying to myself, well, what would make this be equal 6? Well, if this was, the stuff in here was equal to negative 6, well, that's what I'm solving, that the stuff in there is equal to negative 6. Or if the stuff in here, well, here it is, equals positive 6, because the absolute value of negative 6 is 6, and the absolute value of 6 is 6. So that's the reason that it works. And then I just got to solve both of these pieces. So I get negative 2x equals negative 7, dividing by negative 2. gives me x equals 7 over 2. Negative 1 on each side there gives me negative 2x equals 5 divided by negative 2. X equals negative 5 over 2. So those are my two solutions. X equals 7 over 2 or x equals negative 5 over 2. Yeah, you got to give both answers, even though there's an or in between them. If I want to check it, I would check it in the original right there. And I'm going to check it with the answer key. So I'm going to say negative 7 over 2. So I'm putting that in the answer. So negative 7 over 2. And I'm going to have the absolute value, which I'm going to have to find on this calculator. So I got to get my glasses off so I can see it good enough to find the ABS, absolute value. There it is right there. And so it's a shift key. So shift, and then I'm hitting the absolute value. And I want negative 2 times the answer plus 1 minus 2. And when I hit equals, I get, I put it in there wrong. Do you see how my minus 2 is inside the absolute value? Sorry. Not supposed to be inside the absolute value. The plus 1, and then on the outside, minus 2. And then I get 9. Oh, because it changed the answer. Oh, that's why that's not such a good idea, because I had put it in wrong first, and then my answer wasn't any longer negative. Oh, and it wasn't even negative 7 over 2. It was positive 7 over 2. Positive 7 over 2. Okay, we're going to try it again because it wasn't giving me the right answer. So that tells me the answer should have been 4. So that tells me I have something wrong. So absolute value, negative 2, that answer, plus 1. And then on the outside of the absolute value, take away 2. And I'm thinking that should be 4. And there it is, 4. Now, if I want to try the other answer, which was negative 5 over 2, so negative 5 over 2. And so I got that in there as the answer, so I'm doing the absolute value again. And negative 2 times the answer, so that's negative 5 over 2 plus 1. On the outside, negative 2, that should be 4, and they both work. If they don't work, then that means you should find out what's wrong, right? So I had it not work just now. Now, did I have the wrong answer? No, I actually didn't have the wrong answer. I put it in my calculator wrong. That can happen. And so, anyway. So, here I have square root. When you have square root, just like when you have absolute value, you got to get the square root all by itself. And you got to pause and look at what you got. And so I got a square root equals negative 2. And whenever your square root equals a negative, I hope that you remember that right here, this can be positive, it could be negative, which is negative, or it could be a variable, and 0 goes with positive on square root. And so those are the 3 things that we learned about in our class. Positive and 0 are treated the same way. With square roots, negative is treated different. Do you guys remember what that? And square root of any number is always positive. So this is positive always for every value. That's negative. They can't ever equal one another, so this is no solution. And believe it or not, we're finished with number 6. And now we're doing number 7. Got logs. I got logs like I got frogs. And polywogs. Well, that reminds me, I gotta water my garden. Not tonight though. Tomorrow morning, first thing. Okay, so when you got logs, you gotta boil them down to 1 log, and you have your properties for putting logs together. I have a plus in between, so when you have a plus in between, these are both base 4, and I got this plus in between. Do you guys remember what you do when you have a plus in between? I was going to write the property, and then here I have written, instead of the property, I've written what I got right there. That could happen to you. It could happen to you when you're trying to write the property. Let's see, I'm going to call this B, and I'm going to call that M. That's what they called it in our book. And then they called this other one B and N. Well, I might be remembering the B and the M from a different book. But you multiply them together. I hope I've given you enough time to think about what it was. You multiply them together. So this is log base 4 of And then I'm going to multiply these together. X times x plus 6 equals 2. If it bothers you, multiply that together. Log base 4 of x squared plus 6x. Hot diggity dog. And then now you got to use your property that gets it out of log. Out of log, out of log, you got to say to yourself, that's what I got to do. So that property looks like this. If you have a log and a base and an input, and that equals some number, and they call that number the exponent. And then you can write it like this. The base raised to the exponent equals the input. And so these two forms, if you can massage it into that, if you can make it into that looking like that, then you can use the get it out of log property and get it into exponential form, and sometimes that helps you solve it. So if I do that, our base is 4, our exponent is 2, equals x squared plus 6x. So that's 16 equals x squared plus 6x. So that means if I take away 16 from both sides, because it's quadratic and I want 0 on one side, so I have changed it. Did anyone say that logs are must check? Well, if I didn't say it before, I'm saying it now. Plus 6x minus 16. And you guys are like, we've done this problem so many times. Have we done this one so many times? It's x plus 8, x minus 2. So x equals negative 8 and x equals 2. I feel like we did this one on the first lab, on that lab 41. 49, not 41. When you have 51 labs in a class, you can get confused. But I feel like this problem has been here twice. You know me. I reuse problems so many times. I know for sure. You're like, nope, this problem was, oh, you know where it was? It was on the makeup test. Because I know that I've solved this problem a number of times. So when I check it, where else was it? Log base 4 of negative 8. Maybe I did it in class. That's what it was. Log base 4 of negative 8 plus 6 equals 2. And when you put that in your calculator, log of a negative is not defined. And I don't know if you guys remember, the input to a logarithm can't be negative. So that's what makes this extraneous. Just that part right there alone is math error. Even if you went here and added on the rest of it, the calculator would say, you haven't changed anything, friend. It's still math error. And so, but it's because of that part right there. And so that means that this is not a solution. So when I was checking x equals negative 8. Now that doesn't mean anything about x is 2. So I'm going to check it. Check x equals 2. So log base 4 of 2. So that's not negative, so well, it should be okay. Log base 4 of 2 plus 6. That's not negative, so that should be okay. And so when I put this in, if I haven't made any mistake, it should equal 2. If I've made a mistake, then it won't equal 2, and I'll start again and try to figure out where I made my mistake, and I'll probably do some cussing or something. I don't know. Don't usually do cussing over making a mistake on a math problem. I usually save that for if I drop something on my toe. And so I've just put this in right there, and hit equals, I get 2, hot diggity dog, I say to myself. So my answer is x equals 2. Logs are must checks. And so square roots are must checks. Rationals, when you have fractions, it's must check. This is just asking me to factor. It's not asking me to solve. So I've been doing a solving, solve, and then all of a sudden factor. And so I'm looking at it. It's got 4 terms. And I realized that, hey, we haven't reviewed factoring 4 terms yet. And so how you factor 4 terms is you look for a common factor for all 4 terms, which this one doesn't have other than 1. And then what you do is you group the first 2 if they're in descending order, and they are in descending order. And the common factor here, because it's binomial, so I think common factor, difference of squares, cube, because it's binomial. Well, it's got a common factor of x squared. Bring down that sign, minus, and then you're looking at the grouping those together, and you're looking at, well, do they have a common factor? Are they a difference of squares? Are they a cube? And yeah, they have a common factor of -9. I already have the negative out here on purpose. So I get x here. A lot of times people will put -6 here, and these have to be the same, and if they're not, you've made a mistake. And you can kind of see that a negative times a negative is not a negative, and so you really need a positive here. And then it will work, and they are the same then. So you get like a chance to fix it. And then if they are the same, then what you're going to do is you're going to factor that out to the front. So that's x plus 6 times, and you're factoring that out. Well, x squared minus 9. X plus 6 is all done, so I put it on my answer line. X squared minus 9 is a difference of squares. Sometimes it's all done, but this time it's a difference of squares, so that factors as x, right? X times x. Plus and a minus when you have a difference of squares, and then 3 times 3. And then done, 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 dun, dun, dun. One more. Hot diggity dog. What is it? It's a graphing one. I love graphing. I'll be happy doing a graphing one. And so it says, find the slope, the x-intercept, and the y-intercept, and graph the line. And, okay, so I'll start off with finding the intercepts, and then I'll find the slope after. But you do you, whatever one it doesn't matter what order you do it in. So x is 0 is going to find me an intercept. And when I do that, I'm going to divide by -3, so I get 3. When y is 0, put my finger over that, I get x is -9. And that's a little bit off my graph, but that's okay. I think what I'll do is I'll try to get one more thing on the graph, and then I'll just to have, because this one here, -9 is over here. -7's right there, and then -8, and then -9. So I was just thinking if I pick something else, I might stay on the graph a little tiny bit better. And like when x was picked at -9, now if I'm looking here and I'm noticing x has no coefficient, maybe it'll be easier for me to pick y. And between 3 and 0, I started getting off the graph. So maybe I better pick y as 1. So if I pick y equals 1, let's just see if it works out good. It might not. X minus 3 times 1, that's good, equals -9. Then I'm going to add 3 to both sides. And I can see that, oh, that's going to turn out okay. That's going to be -6. So we started with y as 1 and got to x is -6. So -6, 1. And that is on the graph. So I'm going to have here -6, 1, and 0, 3, 1, 2, 3. And I'm going to use I don't have a ruler today. I brought home a ruler that I thought was really cute from my office, because I thought it'll be so cute when I do the videos to use this ruler. And then I didn't get it in the house. I don't know where it is. And I'm using just something that's happened to be on my desk. And you can kind of see that if this is -7, -8, -9 is going to be right where it hits the x-axis, right? So right here, x-intercept -9, y-intercept right here at 3. Now, when I go to find the slope, I have choices. I can use the slope formula, m equals y2 minus y1 divided by x2 minus x1, and use these points right here. Or I can take that equation right there and rearrange that equation so that it's solved for y, and then the slope will be the coefficient of x. So I have choices. The other choice that I have is that I can count it on my graph. So literally all 3 of the ways that they asked me showed me how to find slope are possible here. And so you do whichever one that you want, and you will get the same answer no matter which one you do. So I am feeling kind of like having a bowl of ice cream. And so I'm thinking about counting. So slope equals rise divided by run, right? And I'm going to start here at this point. I'm going to run 1, 2, 3, 4, 5, 6. And then from here, so I was here, and then I'm going to rise up to 1, 2, so up 2. And when I reduce, that's 1/3. So that's my slope. And hats off to the people that I saw solve for y, got the same answer as me. You get the same answer no matter which one of the 3 methods that I discussed you could use. All of them are good. And hey, those are some things to review for your final. And so anyway, hey, that's not too bad. Class coming to a screeching halt. And so let me see here how I stop this video. I'll say good night. I made 3 videos, and good night.